Hey guys, what is up? Hope all of you are doing absolutely fine. I am Parikh, working as a software engineer in a product-based company and having around 3+ years of experience in the IT industry. So in today's video, we are going to solve an interesting coding question which have already been asked in many IT companies, including top product-based companies and big tech companies, including Amazon, Google, Meta, Microsoft, Apple, Uber, LinkedIn, and many other companies. And after watching this video, I'm damn sure that you will be learning a lot more important things and not just the solution. Why? Because when we are starting to solve DSA problems, our main focus should be to improve our logic building skills. We won't be directly jumping into the solution, but step by step, slowly improving our logical skills so that we can reach the solution in the right way. So yes, in today's video, we'll be doing the same thing while solving this question called most common word, not directly, but step by step, slowly approaching in the right way. So yes, let's start with the problem straight away. You can see the question on the screen. The problem is most common word. So here basically we are given a paragraph which is a string and a band words which is array of strings, right? Called band. Now we have to return the most frequent word that is not band. And yes, it is guaranteed that there is at least one word that is not band. And the answer is unique, which means there are no duplicates. We'll have a unique answer. Okay. And the word paragraph is case insensitive and the answer should be written in lowercase. Okay. So let's understand this by some examples. We are given two inputs, right? The first is paragraph, which is a string, and one is the band words, which is an array, right? So let's say paragraph is A, B, B, C, B, B. Here is the white space. Okay. And we have a band words, which is an array, and the band words are A and C, for example, right? Here is the second example. Let's say A, B, B, C, comma, D, T, and the band words are C and D, T. Similarly, let's say paragraph is A, 4 times A, and there are no band words here. One another case is A, uppercase double A, C, CD, and uppercase CD. Band words are A and double A. So now we have to return the most frequent word. For example, let's say here there are 4 words A, B, B, C, and B, B, right? And the band words are A and C. So what is the most frequent word? BB, because A and C are already banned, so we won't consider it, and BB is occurring 2 times here, right? So BB is the most frequent word. Similarly, let's say in this example, the banned words are C and DD. So we'll ignore C and DD from the paragraph. Which are the remaining words? A, B, B. So what is the frequent word here? A, right? Because it is occurring 2 times. BB is occurring only 1 time, right? So what would we written here? A. Understood? Awesome. Similarly, let's say here we have only one word, that is 4 times A, and we have no banned words here. So we would simply written this 4 times A. And here A is banned, so we would ignore this. And what is the other word? Double A. So it is written here that our answer should be in lowercase, right? So we would also ignore this, because if we convert this to lowercase, we would get the banned word, this one, right? So we would also ignore this from the paragraph. So what are the remaining words? C, CD, and CD. If we convert the uppercase CD into lowercase CD, we will have this as the frequent word, right? Because it is occurring 2 times. So we would written CD as the answer, right? I hope the problem statement is clear. But so now comes the important thing. We also need to look at the constraints here, right? What are the constraints? As you can see, we have been given the constraints here. Constraints are basically, we can call it as limitations or some requirements that we need to fulfill while writing a solution. Okay, so what are the constraints here? Paragraph here, that is a string. Its length can be from 1 to 1000. Okay, and paragraph consists of English letters, space, or one of the symbols. So these are the symbols that we need to consider, right? And the band word, which is an array, the length of that array can be from 0 to 100, and the value of the element inside band array can be from 1 to 10. So basically 10 characters. Okay, and each element of the band array would be in lowercase only, right? So these constraints would help in building our logic in the right way. All right, so now what would be our next step, which is again important. If we are a beginner, then we should always start with the brute force approach, which I also call it as a straightforward approach. We don't need to overthink much right now. We only need to focus on what is coming in our mind at the first place to build our solution, to at least start with. Okay, once we reach our solution, we'll see what we can improve, how we can improve, and take the next step to optimize it. Okay, but for now, we don't need to consider the time complexity or space complexity. Whatever is coming in our mind, we'll go with that. We'll start with that. Okay, so yes, one more point I would like to highlight. The paragraph consists of English letters, space, or one of the symbols. So let's say if we have a sentence like, are we going to dance today? So let's say this is also one paragraph which has a symbol that is mentioned in the constraints, the question mark. So why is this important? Because we will have to break down this paragraph into words, right? Only then we'll be able to compare with the banned words, correct? So this is our first step of our brute force approach, that we would break down the paragraph into valid words and then compare it with the banned words. So let's say this is the paragraph and we break down into words. What would we not consider while breaking down this paragraph into words? The symbols, right? And the white space as given here, space or one of the symbols, because the banned words as given will only have lowercase English letters, right? And no symbols. So while breaking down the paragraph into words, we will remove these symbols and just look at the English letters, right? So valid words here would be are we going to dance and today, right? We would ignoring all these white spaces in between and also the symbols, and then we'll compare with the banned words. Let's say banned words are we going and today. Okay, so after we are done converting this paragraph into this set of valid words, which will be an array, we'll compare these valid words with this banned words, right? So now next question would be, how will we compare this? So after forming these valid words as an array, we will traverse this array and check if the current word, that is the current word, is part of the banned words or not. If yes, then we would ignore it. But if the valid word is not the part of banned words, then what? Because if that is the case, then we would have to track the count of that word to basically check that if that word is a frequent word or not. Correct? So we would have to maintain the list of words that are not part of banned words with their count, right? Because higher the count, the more frequent is the word, which will allow us to reach to that answer. So what would we do now? We will need a data structure to store that list. Yes, so here we will take an object. If you are not familiar with the term object, it is also called as maps or dictionaries in other programming languages. Basically, an object is a set of key value pairs defined with key and value, where key is the string and value can be any type, string, number, array, another object. Okay, so now let's say we are traversing these valid words. If we find that any element is part of the banned words, we would ignore that, but the rest words we would keep on adding to our object. Let's say in this case, the word are is not part of the banned words, right? So we will add that in our object, and value would be the count. Okay, so that we can directly access the count here. The next word is we. Is we part of the banned words? Yes, it is. So we would ignore it. Next word, going. Is going part of the banned words? Yes, it is. We would ignore it. Is to part of the banned words? No, right? So we would add it in our object. Is dance part of the banned words? No, right? So even that we will add it to our object with count 1. Is today part of the banned words? Yes, it is. So we would ignore it. Now we have list of all the words that are not part of the banned words along with their count. So what would be our next step? To find the frequent word from this list, basically from this object. In this case, as all the words are occurring only one time, we would return the first word. But let's say 2 is occurring 2 times, then we would have to return 2, right? So we would simply traverse this object, look at the most frequent word and return it as the answer. But we will also have to maintain a max count here. Why? Because when we'll be traversing all the keys from this object, we won't be knowing the max count, right? So we would keep on updating the frequent word along with the max count. And how would we update these two variables? Let's say our max count is 0 initially, okay? And frequent word is an empty string. Now, once we start traversing all the keys, so for each element, we will check the values and compare it with the max count. So let's say in the first iteration, we would compare 1 with 0. Is 1 greater than the max count? Yes, right? So we would update max count with 1. And whenever we are updating the max count, we will also update the frequent word. That is, here R would be the frequent word. Now, in the second iteration, we will check if 2 is greater than 1. Yes, it is. So we would update 1 with 2. And we would also update the frequent word with 2. Okay. In the third iteration, dance is having 1 count, right? So is 1 greater than or equal to 2? I'm really sorry it is getting a bit messier, but is 1 greater than 2? No, right? So neither we would updating the max count nor the frequent word. So after we are done checking all the keys, we would just return the frequent word because that is our required answer. Correct? Now let's look at the algorithm. As you can see the solution here, I have used JavaScript as the programming language. I've taken 3 variables here. One is the object that I have used here to keep the track of the valid words with their count. Next is the regex pattern, which has the list of all the symbols that has been given in the constraints. And word is used to basically track the current word. So what is the first step which we are doing here? Traversing the entire paragraph from 0 to n. Now in all the iterations we are checking whether the current character is part of the regex pattern or not. The English letters won't be part of the regex pattern, but the symbols would be part of the regex pattern. So whenever we will see a symbol, we will consider that word as a valid word just before that symbol, right? So if the word is dancing ? We will consider dancing as the valid word. So once the word is formed, the else if block will get executed. Until that, we will just keep on appending the current character into our current word. And once we see a symbol, this if block will not get executed and this else if block will get executed. If the word is a valid word, that is a non-empty string, in that case, we would convert the word into lowercase because we will have to check that the lowercase word is present in the banned words or not, because the banned array will have the lowercase English letters as per the constraints, right? So we'll convert the entire word into lowercase and then we will check if the banned array does not include the lowercase word. Only in that case, we will execute these 2 statements. So let's say the word is R and the banned array has the word dancing, right? So we will check that whether the word R is present in the banned array. No, right? So then in that case, we will execute these 2 statements. What we are doing here, we are taking that word from the object. So let's say currently our object is empty, right? So accessing the word R on the empty object would return nothing. In that case, we will add that word in our object with the initial count, that is 1. So basically what we are doing here, we are appending the word in lowercase inside our object with the count. What would be the count? Let's say if we already have the word in our object, we will just increment the count, else initialize with the default one, that is 1, which means the word has occurred first time. And then we are just clearing that word so that from next iteration we can form the new word, right? So now this if block is for a specific use case. Basically, if let's say the paragraph is ball, it has no symbols, nothing, right? In that case, when we reach the last character, that is L, we will check that whether the current index is the last index. Even in that case, we will execute the same logic as described here. So basically, instead of writing 2 times, we can move this to a function. So next we are taking a max count and a frequent word. Max count we would initialize as 0 and frequent word with empty string. Now we will traverse our object. So basically object.keys of object will return all the keys of the object in the form of array. So basically let's say this is the object. This will return R, V, dancing. Okay, so all the keys inside the array. So this would get initialized to this variable. And now as we have the array, we can iterate all the keys and check whether the value of that key is greater than the max count. We would update the max count with that value and update the frequent word with that key. This will take us to the right answer. And after this iteration, we will have our final answer in the frequent word variable, right? Let's run it and see whether the basic test cases are being passed or not. Awesome. All the basic test cases are being passed. Now we will submit the solution, which will run more test cases. Awesome. As you can see, the solution is accepted. So it has passed all the test cases and the runtime is just 43 ms. So yeah, that was it with the question. I hope now you are getting to know where should we start from, how we should approach a problem, and then step by step reach to the solution. Because I keep this saying every time that solution is not always important, but how we are thinking logically to reach to the solution. Is the approach going in the right direction or not? All these things also matters the most in our coding interviews. So yeah, that's it for the video. Keep learning and keep practicing.